So today we're going to be reviewing the laws of exponents because we're going to be working with exponential equations in the next couple of days. So just a reminder, the multiplication rule of exponents is when you have two values with the same base and you multiply them, you add the exponents. So this would be equal to x to the a plus b. You also multiply coefficients, so if there were coefficients, 3 times 2 is 6, and then x to the second times x to the 7th will be x to the 9th. Just confirmation that why this works for adding exponents is x to the 4th really means you have 4 copies of x being multiplied together, and x to the 3rd means you have 3 copies. So if you really look at it, we have 7 copies being multiplied together, which is x to the 7th. All right, that is the product rule. Let's take a look at the power rule. So the power rule says that if you have a value to a power and you raise it to another power, you will get, you will multiply the two exponents. So we'll get x to the a, b. Just for clarification on why that is, let's say we had x to the 2nd times x to the 3rd. I'm sorry, x to the 2nd to the 6th. We would get x to the 2nd 6 times. That's 1, 2, 3, 4, and 5. And based on the product rule, we would add them all up and we'd get x to the 12th, which is, of course, equal to 2 times 6. Similarly, we can break this back up into groups of x to the 6th. So we can turn this into x to the 6th times x to the 6th, which would be equivalent to x to the 6th twice. In other words, x to the a to the b power is equal to x to the a to the b, or x to the b to the a. So you can technically switch the order in which the exponents are written because they are mathematically equivalent. So once again, this is the power rule. Let's just apply it to an example with a coefficient. So there are two versions of this example, one with the coefficient inside of the parenthesis and one with it on the outside. When it's on the inside of the parenthesis, the power rule will apply to both values, all the terms, matter of fact. So a number has its own exponent, which is a 1 in this case. So this would become 2 to the 2nd times x to the 6th, and the 2 to the 2nd would then simplify to be 4. So if there's multiple terms inside of the parenthesis, you apply the power rule to all of the exponents of all of the terms, and constants have a exponent of 1 normally. In the second example, because the coefficient is not inside of the parenthesis, it will not be applied, the power rule will not be applied to the coefficient, and we will just get 2x to the 6th. So let's take a look at a lot of the division rules, the general quotient rule. So the quotient rule is to, when you divide, you subtract, so this would be x to the a minus b. The reason for that is x to the 5th would mean you have 5 copies of x divided by 2 copies of x, and x divided by x is 1, and x divided by x is 1, and 1 times 1 times x times x times x is equal to x to the 3rd. So by the nature of how things cancel out in the numerator and the denominator, by division, we sort of subtract. Let's take a look at an example with coefficients. So if we had 10x to the 8th divided by 2x to the 2nd, 10 divided by 2 is 5, and then by dividing the x to the 8th and the x to the 2nd, we will subtract and we'll get x to the 6th. Now, in the examples where the denominator is actually has a higher exponent than the numerator, you actually get a negative number. But we'll clarify that in a moment. So if we were to write this out as x to the 2nd, and this is out as x to the 4th, again, when you divide, you get 1s. So what you really get here is 1 over x to the 2nd, meaning there's more x's in the denominator than the numerator, which can also be represented by x to the negative 2nd. This is actually going to lead us to the negative exponent rule, which pretty much says if you have a negative exponent in the numerator, you can rewrite it in the denominator as a positive exponent, and vice versa. So wherever you have negative exponents in an example, so if we have in the numerator, we can rewrite it into the denominator with a positive exponent, and if we have it in the denominator, we can rewrite it into the numerator with a positive exponent. Keep in mind that all numbers have their own denominator of 1, so we're really just moving the negative exponent terms into the denominator, making them positive, or moving the negative exponent terms into the numerator and making them positive. And that's because there are examples that you're not allowed to have negative exponents for based on the way the questions are worded. So if you have a negative exponent, you can work with it, but your final answer will probably require you to move terms from the numerator to the denominator and denominator to the numerator, depending on what the question was. Let's take a look at an example here. Now, in this case, 12 and 20 don't divide evenly, so we're just going to simplify the fraction. 12 twentieths, 4 goes into them evenly, 4 goes into 12 3 times, it goes into 20 5 times. So the fraction of 12 twentieths will simplify to 12 fifths. X to the 9th divided by x to the 6th will be x to the 3rd, and y to the 10th divided by y to the 15th will be y to the negative 5. And if our answer is not allowed to have a negative exponent, we would rewrite this answer as 3/5, where the x stays in the numerator but the y goes to the denominator. That's applying the negative exponent rule. So if you have a negative exponent, just move it to the denominator or numerator, depending on where it is, and make it positive. Lastly, we have two more rules to discuss. One is the zero exponent rule. So if we have the example of x to the 6th divided by x to the 6th, if we cancel everything out, we should get x times itself 6 times over the same thing, and they will all cancel out, leaving over 6 copies of 1, 1, 1, 1, 1, 1, 1, and if we multiply those out, we get 1. So, which should also make sense because any number divided by itself is equal to 1, but at the same time, by the subtraction rule, this is also equal to x to the 0. So x to the 0 is equal to 1 for all numbers, with one exception. That is if x is not equal to 0, because division by 0 is undefined. So if the denominator were equal to 0, then this rule would not apply. But for all other numbers, to the 0 power will equal 1, because you're really just saying whatever value this is divided by itself. So for instance, if I said 200 to the 0 power is really saying I have 200 to the 1st divided by 200 to the 1st, because they're subtracting equals 0, and this is equal to 1, therefore 200 to the 0 equals 1. And this will apply for everything except the 0 to the 0, which would be 0 to the 1st divided by 0 to the 1st, which is undefined. So this is the only exception, again. So for any number to the 0 power will equal 1, with the exception of when x is equal to 0, because then you get an undefined example. All right, lastly, we have the power of a quotient rule, which means you have a fraction being raised to a power. Since we can rewrite this as x to the 2nd, y to the 3rd, just 4 times, because it's the 4th power, and you multiply the numerators of the fraction, this would become x to the 2nd 4 times, and it would become y to the 3rd 4 times. In other words, we're going to apply the power rule to both the numerator and the denominator. So this would become x to the AC and y to the BC. If we were to finish this example up, we would get x to the 8th and y to the 12th. And that's from adding all of these and adding all of these, or simply multiplying. All right, let's take a look at two more complicated examples. All right, so this is our first complicated example. It has multiple properties being used in it. First, we're going to apply the power rule. So the power rule will apply to both the 2 and the x, so that will become 2 to the 2nd and x to the negative 12. Everything else will stay the same for now. Next, we will simplify our 2 to the 2nd to be a nice whole number of 4, which will make it easier to do the rest of the example. Let's work with the numerator for now. So we'll multiply the two expressions. So 4 times 15 is 60. X to the 12 times x to the 3rd is going to be x to the 15th, but because they're negative, it's x to the negative 15. Next, we will still be dividing by 5x to the negative 8. we will divide these if possible, otherwise we'll have a fraction. 60 divided by 5 is 12. X to the negative 15th minus negative 15 minus minus 8 will actually be x to the negative 7. Now, if we're not allowed to have a negative in our final answer, which you're usually not allowed to, we're going to put this over 1, and we're going to move the terms with the negative exponents to the denominator. So our final answer will be 12 over x to the 7th. Let's take a look at one final example. So in this case, again, we have a power rule. We're going to apply that to the denominator. So we're going to have 20 x to the negative 3 y over 4 to the negative 5. So 4 to the 5th, well, we're going to write it, let's write it all down. 4 to the negative 5th, x to the negative 20. We can move everything at the beginning and the end as well. So I'm actually going to, in this case, apply the negative exponent rules up front. So this will become 4 to the 5th, 20, y. So I moved the 4 to the 5th to the numerator. We're going to move the x to the negative 3rd to the denominator. And we're going to move the x to the 20th to the numerator. So now there's no negative exponents, and we can just simplify the problem as per usual. So this will be 4 to the 5th times 20, y, x to the 17th. So that's by the division rule, or this. Well, we have to just apply 4 to the 5th. So using a calculator, just so I don't make a mistake, 4 to the 5th power is 1024. Multiplying that by 20, we get 20,480, x to the 17th, y. That would be our final answer. If you have any questions, make sure you ask them in class.